The research paper discusses the measurement of valence and stereotypical biases in text-to-image generation models. It proposes a novel text-to-image association test (T2IAT) framework, inspired by the Implicit Association Test from social psychology, to quantify implicit stereotypes between concepts and valence in images. The authors replicate bias tests on generative models, including morally neutral tests on flowers and insects, as well as demographic tests on diverse social attributes. The results demonstrate the presence of complex stereotypical behaviors in image generations. The paper highlights the importance of considering biases in image generation, especially with the increasing use of these models in various applications. It emphasizes the need for a nuanced understanding of biases beyond straightforward demographic biases. Here is a combined summary of pages 3 and 4 of the research paper. Recent studies have examined the ethical considerations related to vision and language models, highlighting concerns about fairness, privacy, and security. This paper focuses on measuring human biases in Stable Diffusion, a text-to-image generative model, but the framework can be applied to other generative models. Biases in vision and language models are well documented, with language models trained on large amounts of text data likely to contain biases. To measure these biases, various systematic works have been developed, including the Sentence Encoder Association Test (SEAT) and StereoSet, which measure stereotypical biases in language models. In addition, crowdsourced datasets such as stereotype pairs, CRO-S pairs, have been created to measure biases in language models. This work adapts the Implicit Association Test (IAT) from social psychology to measure biases in text-to-image generation. IAT is an assessment of implicit attitudes and stereotypes, where test subjects are presented with a series of stimuli and asked to categorize them quickly and accurately. The IAT score is interpreted based on the difference in response times for different categorization tasks, with higher scores indicating stronger implicit biases. The proposed text-to-image association test, T2IAT, quantifies human biases in images generated by text-to-image generation models. The test procedure involves composing neutral text prompts about target concepts, generating attribute-guided images, and measuring the distance between the neutral and attribute-guided images to quantify the association between the concepts and attributes. The differential association measure is used to calculate the difference in association between the target concepts with the attributes, and a permutation test is used to compute the p-value, which represents the degree to which the differential association is statistically significant. The authors propose a novel bias test procedure that adapts IAT to text-to-image generation, providing a systematic method to measure human-like biases in image generation. The work complements prior studies on biases in language models and computer vision tasks, highlighting the need for thorough examination of ethical considerations in text-to-image generation models. The research paper discusses the bias in text-to-image generative models by conducting various bias tests. It starts by explaining the concept of effect size and how it's used to measure the separation between distributions. The Cohen's d effect size is computed for each bias test to classify the bias as small, medium, or large. The paper then presents the bias test procedure, including the construction of neutral and attribute-guided prompts, generating images, and computing the effect size. The experimental setup details the tests conducted, including valence tests for flowers and insects, musical instruments and weapons, and stereotypes tests for science and arts, careers and family, European American and African American, light skin and dark skin, straight and gay, and Judaism and Christianity. The results are presented in Table 1, showing the association scores, p-values, and effect sizes for each test. The findings indicate biases in the models, such as a strong association between flowers and positive valence, and between weapons and negative valence. The study concludes that human-like biases are universal in image generation models, even when the concepts used are not associated with any social concerns. This study examines the presence of hostile and non-hostile biases in text-to-image generative models, specifically focusing on religious, racial, and gender-related biases. The researchers conducted several valence tests to assess these biases, using different sets of text prompts for each category. For religious biases, they found a slight pleasantness towards Christianity and a slight unpleasantness towards Judaism. Racial biases were also explored, revealing a significant association between European American names and pleasant attitudes, and African American names with unpleasant attitudes. Gender-related biases showed that males are more associated with career, while females are more associated with family. Furthermore, the study highlights gender stereotypes in various occupations, with computer programmers and pharmacists being more strongly associated with men, and elementary school teachers, librarians, and chemists being more associated with women. The stereotype amplification test demonstrated that images generated by the diffusion model amplify the implicit stereotypes in textual representations used to guide image generation. The findings suggest that not only non-harmful human biases but also hostile stereotypical biases exist in text-to-image generative models. This research paper introduces a novel approach to measure the implicit valence and stereotypical biases in images generated by state-of-the-art text-to-image models. The proposed bias test is based on the idea that images can be used as prompts to elicit associations from a pre-trained language model, which are then compared with associations elicited by textual prompts. The results indicate significant biases in the generated images, amplifying existing societal prejudices. The study focuses on various dimensions such as gender, religion, skin tone, and occupation, demonstrating how these biases are reflected in the generated images. For instance, the association scores for flowers and insects show a strong preference for flowers being associated with pleasantness, while insects are associated with unpleasantness. Similarly, for musical instrument and weapon, the association scores lean towards musical instruments being pleasant and weapons being unpleasant. The paper also explores the amplification of biases in occupational images, where the generated images exhibit more pronounced gender stereotypes compared to the textual prompts. The findings align with human evaluations, suggesting that the machine-rated association scores accurately represent human perceptions. The authors acknowledge limitations in their work, including the potential underrepresentation of certain concepts in the verbal stimuli and the potential for the image encoder to introduce additional biases. They emphasize the need for further research on this topic to ensure fairness and ethical considerations in AI-generated content. The paper concludes by discussing the implications of these findings for practitioners, highlighting the importance of being aware of these biases in AI-generated images. It also references other studies that have explored similar issues, such as gender disparities in commercial gender classification and the presence of human-like biases in language models. In summary, this research provides a valuable framework for measuring and understanding the complex biases present in AI-generated images, contributing to the growing literature on AI ethics. Here is a combined summary of pages 11 and 12 of the research paper. This paper surveys various studies on bias and fairness in artificial intelligence, particularly in language models and image generation. The authors draw on previous research to highlight the importance of addressing bias in AI systems, citing works such as Nosek et al. 2002, and Kaliskin et al. 2021, that demonstrate the presence of human-like biases in contextualized word embeddings. Several studies on debiasing techniques for pre-trained language models are mentioned, including Mead et al. 2021, and Nadim et al. 2020. The authors also reference works on measuring social biases in sentence encoders, such as May et al. 2019, and Kim et al. 2021. In the context of image generation, the authors cite papers on text-to-image synthesis models, including Nikal et al. 2022, and Rambach et al. 2022. They also mention studies on detecting and mitigating biases in image generation, such as Shaw et al. 2023, and Steed et al. 2021. Furthermore, the authors discuss the importance of fairness and accountability in AI systems, referencing works such as Wang et al. 2022a, and Wolf et al. 2022. They also highlight the need for diverse and representative datasets, citing studies such as Shankar et al. 2017, and John et al. 2022. The authors conclude by emphasizing the need for continued research on bias and fairness in AI, highlighting the importance of developing more robust and equitable AI systems. They also provide additional experiment details, including verbal stimuli for bias tests, in the appendix. Overall, this paper provides a comprehensive overview of the current state of research on bias and fairness in AI, highlighting the importance of addressing these issues to develop more trustworthy and equitable AI systems. The research paper discusses various concepts and attributes, including verbal stimuli for different objects, people, and ideas. It categorizes these stimuli into groups such as flowers, insects, musical instruments, weapons, and human names, among others. The paper also touches on skin tones, sexual orientation, and religious beliefs. Furthermore, it covers career, family, and scientific fields. The authors present these categories with a focus on their attributes, such as pleasant and unpleasant concepts, and male and female gender. This structured approach aims to provide a comprehensive understanding of the concepts and their relationships. The paper also includes a table summarizing the verbal stimuli for each category, enhancing the clarity and accessibility of the information presented.